To apply these signatures, there were multiple strategies. How to optimize the work of the engine so it's fast and at the same time not false positive prone. One of the strategies would be anchoring around P structure. What I mean by this, instead of searching for the signature in the whole file, the antivirus engine would be searching around certain elements inside the file. And even signature itself could contain a modifier which says search for these bytes in the first section. What would happen is the engine would scan the file, and when it hit the first section, for example .txt, it would only look at a sub part of it. For example, it could say I'm only looking at on the first page of the section and maybe the last page of the section. And so the engine would start searching, and at some point it will find that block of data, right? It triggered. If that triggered, then only then it would actually continue executing the signature. And the second part of the signature can vary in size again, can be small, most of the time would be small, sometimes can be big. It honestly doesn't matter because it only stores CRC of it. This actually can say, well, for this, search for second section. Antivirus would continue the scan of the file, and it would, for example, also search elements in the second section. And it would search, and boom, it found that signature as well, as that part of the signature as well. And then it might have a third component of the signature would do the same thing and search something in, let's say, experts, and that triggered as well. And the scan would be, in this case, I draw it a bit awkwardly, right? It's not usually how you draw the PE file, but the scan would be from left to right, from beginning of the file to the end of the file. If your first bytes applied in the section 1, you couldn't search the second part of the signature in MZ header because we already scanned the MZ header, we couldn't come back. It would be sequential application of the parts of the signature, so you couldn't go backward because that would kill the performance. So you scan the file, and instead of scanning the whole thing, you actually scan around of every anchor, and around this anchor you would scan only certain area to see if a sub part of the signature triggers, and only if it triggers you say okay, that's triggered, and you search for other signatures, and then you see it's like it gets into the queue of things to check in the next area or even in the same area. The other possible implementation could be that you have a first signature triggered, and then you have a distance saying that if this one triggers, search next 100 bytes for the second one, and only trigger it if it's in the vicinity of the 100 bytes, right? This allows you to pivot around those anchors, and it makes signature much more robust because it only triggers if you find some sequence of bytes in vicinity you expect it to find. Of course, some of the signature would be more robust when they designed based on the code which potentially used, and you don't have a very strict distance between a different part of the signature, and some of the signature could be very precise. If you have a bigger size, for example, your second component and third component is bigger in size, and you also use a strict distance between the first component of the signature, second component, the third component, almost becomes too precise, right? But the quality of such signature would always depend on how virus analysts design the signature. Another approach for the signature development would be based on anchoring around the code, not around a PE structure. The engine would start searching from the entry point, and let's say it searches first n bytes around entry point. It could be before entry point and after entry point. If the first component of the signature, and so when it searched through this first area, it's not just pivoting, saying, oh, 100 bytes from here and 100 bytes from there. Instead, it's following the jumps. Let's say in the code here, there is a jump into this area in the file. So the next area the engine would scan would be around that jump, that location to that jump. And let's say this jumps somewhere here. That's where engine would scan, right? So in this case, you again have a chain signature. The first element you find to generate false positives you want to cover as many malware samples as possible, so it's a balance between being too precise or too slow, because the more often that first element triggers, the slower the engine is going to work, because it needs to apply the second part of the signature. So when your first signature, which is short, let's say triggers somewhere here in the second block of file, only after that, the engine would continue searching for the second part of the signature, and it will only continue searching it either in the same block, if it's specified, or in the next block after the next jump, right? And then code comes back somewhere here, and the third part of the signature triggered somewhere here. This way you really create a code-based signature, which will only trigger if certain functions inside the code is linked to each other. And the important thing is, it's not necessarily functions which are directly linked to each other. It might be a function which indirectly linked, meaning the function A calls function B, C, D, and then at function E you have a second component of your signature trigger. That allows you to be very relative in terms of where the signature located, because even if malware recompiles the code and relink it, so the location of the functions inside the binary would be different, because it's not based on absolute location or location anchored to a P structure. Instead, it's based on location around the code, and it follows the code. It can be much more efficient. Of course, it's not always possible to follow the code. Sometimes you can have indirect jump, for example, jump EIX. Then if you just statically disassemble the code, you actually have no clue what EIX is. And in this case, that signature breaks. So that's why CPU emulators were introduced, which we will talk a little bit later about, and how exactly they help develop even more advanced signatures.